Hi, this is Helen Thomas again in the CDFM study group as we continue review of the CDFM Module 2.2 out of the 2018 study guide. All right, I'm going to pick up on page 2234, Federal Acquisition Regulation, the FAR versus acquisition process. And so the procurement agreement, remember, before we can do any type of obligations, we need obligating documents. So we need to know as financial managers what types of obligating documents are out there. So at the bottom of 34, it talks about the families of contracts. You have fixed price contracts where the government pays a price subject to a fixed amount, and cost reimbursement where the government pays the cost subject to limitations of allowability and so forth, as mentioned there. So in fixed price, what you need to know between the fixed and the cost reimbursement is who takes the risk. So in the fixed price contracting, the contractor promises to deliver for a specific price. And so if a contractor is late in delivering the product or his or her product does not meet the specification for acceptance, the government may terminate the contract for default and not pay the contractor. So in some circumstances, the government will re-procure. They'll buy the item. So clearly, in a fixed price contract, the contractor takes the most financial risk because they have a base fixed. That means no matter whatever it costs me, it might cost me more. That's going to be the fixed cost. So in the fixed cost, the contractor or the vendor takes the most risk, financial risk. In a cost reimbursement contract, the government promises to pay whatever it costs that contractor to do the job. So the government is the one that will assume the most risk, financial risk, in a cost reimbursement type contract. So in the financial management world, you continuously hear the term earned value management system. And so you got to be familiar with it. So the government imposes EVM reporting requirements. So those are reporting requirements between the contractor and the COR, contracting officer representative. The DODI 5000.02 prescribes the type and level of reporting required, which is customarily based on the value of the contract. So depending on how much, couple of thousands versus $1 million contract, there are different requirements. So earned value management system is that process of reporting to measure contractor performance. So it mentions a little bit more about the EVM and contractor performance on the bottom of 35. Let's flip to the next page. And Earned Value Management Overview is an integrated tool. So it's used between the government representative and the contractor to make sure that the contractor is staying along the cost, the schedule, and performance. What are they expected to be done at a certain time? What are they expected to do? And making sure that we stay on target in each of those phases. So this is repeating the requirement versus out of the DODI, the DODI 5000.02. And it talks about the performance measurement baseline is used for tracking contract performance. So that's what I say. You're checking your cost, your schedule, are we on schedule, and performance, meaning are they producing what they're said they're going to produce at a certain time. So EVM is one of DOD's and the industry's most powerful program planning and management tool. Both the government and the industry participate in setting the 32 guidelines and other aspects of the EVM standards. So standard is set in what's going to be used to evaluate that contractor. So I do know that you're going to have to calculate the budgeted cost of work schedule, the average cost, and so forth as listed on 36 and 37. So let's see what we have here. So budgeted cost of work schedule. This performance measurement baseline may also be considered the planned value. So you got to look at what did I budget for, what actually happened. So that's what you're doing, comparing your planned versus your actual. So in these, don't let this confuse you with the earned value management and the terms used. Is basically that's what you're doing. So when you do the earned value management, you're sitting down, you said, okay, it's going to cost $50 to do this job. Now you're telling me it costs $55. So you spent over the amount, and you got to make sure, find out why. And so earned value management reporting continues. What is a performance assessment, root cause analysis. See, these are things you can read, so that's why I'm just going over these. All right. Earned value management report analysis. So let's go now to the cost variances. Is a result of comparing your actual cost versus your budgeted cost of work performed. Can be considered earned value of work. Because sometimes they said the value of the work that I'm doing. Think about it, if you're doing a renovation on your house. The value of your house may be $170,000. Once you add a sunroom, now the value of your home went up to $180,000, but it only costs you X amount of dollars to add that sunroom. So, but the overall value to you has expanded. So that's kind of what earned value management is. So make sure you review the schedule variance and the cost variance, because I do know you're going to have to. You might see that again. So on the next page, on the diagram, earned value management, it kind of shows you. So you really have two charts in one. So you have project A, B, and C. The budgeted cost of work schedule. So that's my planned work and cost. And then you have the budgeted cost of work performed, value of the work done, and in between that you have the schedule variance. So let's just look at 1, 2, 3, the first four columns. So you see it says budgeted cost of work schedule. That means what I had planned was $487. The value of the work done was $487. So I am on target. The second one says I plan to spend the budgeted cost of the work schedule was $250, but the value of the work done. So we're comparing the BCWP, budgeted cost of work performed, is the value of the work, but the value of the work was only $217. That's what makes it unfavorable. So the best thing is the ones that begin with BC, when you're comparing the BCWS and the BCWP, is looking at the value of the work. So if the value of the work planned was $719, and then the value of it once the work is done is $847, it's more, so it's favorable. Now put your hand over the first three columns. Let's just look at the last three. Budgeted cost of work performed, so the value of the work done versus the actual cost of work performed. So this is saying we're talking cost now. So the value of the work was $487. The actual cost was $487, so I'm on target. The value of the work was $217, but it only cost me $122 to do it. So that's favorable. The budgeted cost of work performed was $847, but the actual cost was $875. That's more, so it's unfavorable. So you have to take this chart like in two. Schedule versus value, then value versus actual. And then you'll it's easier to process in your mind whether it was favorable, unfavorable, or on target. And we like charts, so whenever you come up with the value, you can do your program evaluation and review technique. You can use the PERT diagram where you list the event and the activity, all the things that's supposed to occur, the timeline that they're supposed to occur, and it talks about events and consider the node, activity, critical part. You can read through that, and the project timeline. Or the Gantt chart. This chart is also useful for planning and scheduling products. So make sure you know PERT and Gantt, the different types of way to display the job that's being done and the different work that needs to be done to get a final end product. All right, let's talk about economic analysis. I get excited about economic analysis, where you look at if you're having to estimate a cost today for something that is going to take you 5 years to do, you have to look at the current dollar today and discount that dollar to know how much it's going to cost to produce something that you need in the future. So economic analysis is that systematic process that we use to choose the best method. Is it better to lease, to buy? So those are the kind of things that we want to answer. So you can read through the steps, the process, how to identify benefits. Remember, benefits are not always quantifiable, where you can put a dollar amount on it. You can also have non-quantifiable. However, make sure you know that the quantifiable benefits of choosing option A over option B or B over C or whatever is cost savings. Am I saving any money? Cost avoidance. Am I avoiding to have to pay something else? So if I get rid of my car, I'm avoiding having to pay car insurance, car payment. I'm saving money. Or productivity improvement. I can show that my productivity have improved from 1 month to the next. So I can put a number on it, quantifiable benefits. So examples of quantifiable benefits listed on the next chart. You can read through those. And then the non-quantifiable benefits are those things like, is it available? Availability, functionality, adaptability. Can it adapt to the climate, to the change? Can I add other system to it? Morale. Does it improve morale of my personnel? So these are different non-quantifiable. So when we do cost estimates, it's not simply, well, let's pick the cheaper item. Is you have to look at what are the benefits associated with your decision. So that's what the non-quantifiable benefits are. And the whole list is on page 48. So now we jump to statistical overview. So once we get our data and we start doing analysis of our results, what does it mean? What does all this data mean? So statistical methods that we use are descriptive statistics, for instance. Measures of central tendency. What is the tendency for that item to produce the same thing over and over again? The mean, median, and mode, you're going to have to calculate. What's the mean? The mean is the average. So if you get a list of 10 numbers, you add up all 10, and whatever that total is, you divide by 10, that's your mean. Your median is the middle number. Let me point something out to you. If you get a list of, let's say, 10 values, you have to put those values in numerical order to be able to calculate the median or even the mode. Mode you can figure out because it's the most repeating number, but the median is easier if you put all the numbers in numerical order, because sometimes let's say you have 1, 2, 2, 2, 3, 9, 10. When you do the median, you put them all together in numerical order, you'll be able to see, okay, which are the numbers in the middle. And if it's 2 of them, I need to take the average of them, so it might be 2.5 or things like that. So the median is the middle value of the list. So whenever you have a list of values, put them in numerical order. Just make that as a practice. And it makes it easier to calculate the mean, median, and the mode, the most repeating, frequently used score. Measures of dispersion. So central tendency is reveal how the data are grouped. How much, every time you repeat that data, is it primarily the same amount or different values? What's the central tendency? And the measures of dispersion. How wide, how close is your range of dispersion? So in there, you're going to have to calculate the range, and you may possibly have to do the standard deviation. So the range is often, you take the higher value, subtract the lowest number. So if you already put them in order, you'll know which is the higher value, the bigger number, and you'll know which is the smaller number. And the range is simply subtracting the smaller number from, so if you have a number 1 through 10, you take 10 minus 1, so your range is 9. And then the standard deviation is given at the bottom. For 1, standard deviation is 68.27%, 2, 95.45%, and 3 is 99.73%. So standard deviation has many uses in economic analysis. It helps to quantify cost, risk, uncertainty, because if you do your standard deviation, if everything is close to the mean, it's easier to say, okay, I can trust that value. But if your standard deviation is all over the place, is 3 standard deviation, and the values are just so dispersed, you might not be able to trust that data. So just because you produce a data, you have to understand, what does that data mean? And then the third is frequency distribution. So now we come to our charts. So there's different ways to show your chart. You can either use your histograms, and the histograms commonly known as the bar graph, which is on the left, or a frequency polygon, which is on the right, where you put the dots and then you draw the line to connect the dots, and you can see the curve. You could see the bell curve. Now, oftentimes, you may see where your bell curve is skewed, meaning your data is like, why is everything shifting to the left or to the right? So you can have skewed distribution, where it's not a perfectly curved bell curve, where everything is evenly dispersed on your graph. So skewed distribution could be positive or negative, meaning that the things you are comparing, either they positively affect each other or they negatively affect each other. This is the best way to look at that. So a positive skewed distribution, because the tail falls off to the positive direction, and then the negative, if you look, so on the graph, so it's best to look on page 52, where you can see the diagram at the top, the positive and the negatively skewed data. So let me read the example they list here. For example, in a sample of a shop repairing a piece of equipment, we would expect the technicians to repair the equipment in a specific period of time that is used in automated repair shops to give an estimate time to repair a problem. But in some instances, the equipment repair may take longer than expected. We can see this in the chart time to repair, showing most of the data on the left. This is described as a positively skewed distribution because the tail falls off. So make sure you read through that. More calculation. Proportion. Whenever you hear proportion, just think, okay, that's some type of a percentage. I'm going to have to calculate something, and the end result is going to be a percentage. So proportion typically means you're dividing a small number by a bigger number. So proportion is a statement of quality between two categories. So if you talk about the number of times an individual in one category divided by the number of items or individuals in all the categories, it will give you the percentage. And the examples at the bottom, make sure, because this one can get confusing for some. If I'm talking about having inventory in my store, your supply department had 100 engines in inventory on January the 1st. On February the 1st, your engine inventory was only 75. By what percentage did the inventory change? Now, for most, you might just say, okay, well, what's 100 minus 75? It's 25. Is it 25%? Okay, you might be able to guess the 25%, but that's not how you calculate percentage. So they gave you the formula at the bottom. So you take the 75% minus the 100, will give you the negative 25, divided by 100 times 100 gives you negative 25%. So the decreased change in inventory was a negative change. If you do not follow this example and do it this way, you will probably not know it's a negative change. You will probably just say, okay, I think it's a 25% change. Is it positive or negative? And I guarantee both of those answers will be what those choices that you will have to take on the exam. So do it like this. And then the second step says on March the 1st, same example. So remember we had 100 and now we had 75. So that's a negative 25% change. Now this other one says on March the 1st, your inventory was again 100 engines. By what percentage did the inventory change from February to March? So it's back up to 100. So following the same example, it says 100 minus the 75 will give you the 25 divided by 75 times 100. And that should give you, let's see, 33%. So the 33% change in inventory was a positive change. So it's a positive 33. Let me go ahead and write that in. My book is new. I didn't have it written in. All right, so 33%. So the 33%, so the increase change. So we went from 75 to the 100. So an increased change in the inventory, therefore, was a positive change. All right. I'm just writing the answers in my study guide, so bear with me. All right, so measures of correlation. Does the data that you're comparing correlate with one another? What are you comparing? Significant benefit of that inferential statistic. And so I'm going to jump to page 55, 2255, where it gives you the diagram. Measures of correlation. It's either positive correlation, negative, or no correlation. So based on the data. So if you look at a plus 0.85, positive correlation means that the data is consistently comparing examination scores to productivity. So the higher scores that the people made showed that their productivity increased. So these individuals went to a training, like you go to a school, you go to training. Then once they come back, you're evaluated on how did the effectiveness of the training that you went to. So positive correlation shows that the people that scored higher on the exams increase their productivity over time. So that means the training helped their productivity. A negative correlation is if I compare examination scores to the number of errors that you make. And so it's a negative. It doesn't really, let's see, data in the middle chart indicate there's a strong negative relationship between training scores and the number of errors made by the test takers. Therefore, it can be assumed the higher the training score of an individual, the fewer errors that individual will make. This indicates that the highest scoring individual would be more productive. So that's when you can actually see, oh, that data can make some sense. So negative correlation is the highest score, less errors. And no correlation is the zero correlation, which simply means that if I'm comparing examination scores to age has no impact on how they perform at their job. So know the different types of measures of correlation. Coefficients of determination, coefficient of variation. I'm not sure if I've seen anything, but make sure you see the formula for your CV, coefficient of variation, and look through page 56. Know the difference between constant dollars and current dollars. So constant are the result of having the effects of inflation removed. So constant meaning even if I'm doing the cost estimate, but I'm not considering inflation. Versus current dollars, I'm looking at the inflation rates throughout the time. Sunk costs, one of those costs that once you expend it, it's done, must be provided in documentation, but you still spent the money upfront. So a sunk cost could be, okay, we have to hire an auditing team to come and do an analysis. So that sunk cost to hire them initially could be that cost that I pay for them to come, which has nothing to do with the actual result. Time value of money. Now, I'm going to pause on this one because, no, actually we're almost done. So let me go ahead and finish this up. So time value of money now with economic analysis is looking at the value of the dollar today, and based on the interest rate, the discount rates that are published, we try to figure out how much it's going to cost in the future. If I have a 5-year project, I know that the dollar is not going to be worth the same today next year. So I have to discount that dollar in the future. So that's what that does. So the end of year, mid-year discount rates, those are typically given to you, those discount rates. And you will then have to calculate a project. And so I think, let me see, the best way to do this, they give some examples, but let me jump to, I think you have to do a project or something. Average unit cost for labor, earned value management, learning curve. Oh, they didn't have the examples. Okay, all right, so excuse me. So you have mid-year discount factor, and you got to make sure you read the question. Are they asking you how much they'll tell you, use the mid-year discount rate and tell me how much this project will cost in 2 years, in 3 years. All right, so analysis of proposed investments. So that's where the example comes in on page 60. So the above chart provides an analysis of a proposed 5-year investment. So it says since year 1 through 5, expected, how much do I expect to pay each year? And then expected yearly benefit, mid-year discount rate, because this one said to use the mid-year. And that means for year 1, the dollar is going to be what it is. So year 0. Year 0 is when you buy the item. And year 1, 2, 3, 4, 5 is the recurring cost of that item. So you will have to discount year 1, 2, 3, 4, and 5, and then add all of that up. So using the discount chart. So for example, back to 59, if I use the mid-year discount chart, year 1 through 5. So that means whatever I pay in year 1, I need to multiply times 0.9804. Get a value. Whatever I pay in year 2, I multiply by 0.9427, I get a value. And so forth, all the way to year 5, multiply by 0.8380 and get a value. And then I add all of that up, and that would be the cost, the discounted cost of purchasing that investment. So make sure you review that, because you'll probably have to do something like that. Break even. So if I invest my money today, how long will it take me to earn my money back? So that's what break-even point is about. So for this particular example, it says I invested $1 million, which I had $1 million. All right. And I have savings. I save, what is it? 50,000. So let's read it. Consider an opportunity for a new system that has $1 million investment cost and an annual operating cost of 50,000. The proposed system will replace the current capability that has an annual operating cost of 300,000. So I'm jumping from 300,000 to 50,000. So 50,000 from the 300,000 is 250. So I do the 1 million divided by the 250, and it'll take me 4 years to get my money back, earn your money back. All right, so on the examples, practical exercises on page, I typically don't refer people to them, but these particular ones will help you with your review of this section. Page 2263, your life cycle cost, that's what I was talking about. So at the top, so this is recapping, check on learning, right? So at the top, you see you have your total RDT&E, prime mission equipment procurement, support items, initial spares, MilCon, O&M, and MilPers. And so all they simply said, what's the cost of the development cost? What's the development cost? So you have to remember development cost is my RDT&E. So that will tell you that's 400 million. Flyaway cost. Flyaway cost was procurement of the prime item. So 600 million and so forth. So make sure you go through 63. 64 tells you how to do the average unit cost and the program acquisition unit cost. And 65 is you have to list the labor cost. So utilizing, so they gave you the learning curve is 90%. And if you take 90% of 190, you should get 171. If you take 90% of 171, you'll get 153.9. So if you take 90% of 153.9, it'll give you the labor hours to the 8 item. So unit 1, 2, 4, 8, and 16, and you'll be able to calculate that. And then the other side is telling you to calculate the learning curve percentage. And so given the below information, determine the learning curve percentage. Note that the learning curve percentage remains constant from 1 unit to its doubled unit. So from unit 2 to 4, use of division is required. So you have to divide, let's see. So you're going to have to divide 595 and your 700. So let me see. Let's make sure that we do that right to get your percentage. So if you do 595 divided by the 700, I got 85%. So let's do 505.8 divided by 595, I get 85. So 85%. And so what you do is if you take 700 and do 85% of 700, you should get 595. So you kind of like check your answers. So I like math, you'll be able to check your answers. 67 is the earned value management. Remember that chart? I tell you it's 2 charts in one. First 4, actually the first 4 planned work versus what was actually done. And then planned work versus the value of the work done, versus actual cost. And so make sure you read through page 2267. All right, this will conclude review of CDFM Module 2.2, the budget and cost analysis. So be sure to subscribe, and I'll see you guys again next time on the CDFM Study Group.